In this problem, you have to choose between two payment options for 30 days. The first one is $10 million each day, meaning the first day $10 million, second day $10 million, and continuing for 30 days. The second option starts small, just with $1 the first day, but then your salary doubles each day, meaning the first day $1, the second day $2, the third day $4, and doubling for 30 days. Which one do you choose? To know the answer, we must evaluate every sum. So, for the first option, we will call it S1, and since it's for 30 days, and for each day we have $10 million, our sum will be just 30 times 10 million, which is 300 million. It's a very big sum. But let's check the second sum, which I choose for me. So the second sum will be S2 equals $1, 1 plus second day 2 plus 4 plus until the last day. Now we must know what is the amount of the last day. So here we have powers of 2, and we will know this number. And the first day we have 1, which is 2 to the power 0. The second day we have 2, which is 2 to the power 1. Third day we have 4, which is 2 to the power 2. And you see here, first day, second day, third day, it's 3 minus 1, 2 minus 1, 1 minus 1. So here, since it's the 30th day, we will have 30 minus 1, which is 29. It's the method to know the last power. Now our sum is 1, S2, is 1 plus 2 plus 4 until 2 to the power 29. How do we evaluate this sum? It's a geometric sum, which is of course equal to 2 to the power 30 minus 1 over 2 minus 1. But I will not accept it just like that. I will go generally and prove to you that for some x different of 1, we have this formula 1 plus x squared plus until x to the power n is equal to x to the power n plus 1 minus 1 over x minus 1. So how I will prove it? I will call this sum to be s, and if we call it, or another term, t, if we call it t equals 1 plus x squared until x n, I will continue here. So if we call it t the sum, we will have tx equals, we multiply by x and we distribute it. So x times 1 is x plus x times x, x squared, plus x times x squared is x cubed, and until the last term, which is xn plus 1. But just before xn plus 1, there is the term xn, x plus x squared plus, until here before xn plus 1, there is xn plus xn plus 1. And if you see here this term, it's equal to this term. So what is equal? This term is equal to, if one goes to the other side, t minus 1. So this term is just t minus 1. We'll have tx equals t minus 1, this term, plus x to the power n plus 1. And finally, t goes to the other side. Tx minus t is equal to xn plus 1 and minus 1 here. It's the same. Now, excuse me here, we'll go back to our sum. Now, common factor t common factor times x minus 1, here t times x minus 1 equals x to the power n plus 1 minus 1. And finally, we just divide. Since our x is not equal to 1, we can divide and get our sum, xn plus 1 minus 1 over x minus 1. Now back to our sum S2. S2 is equal to 1 plus 2 squared plus 2 to the power of 29. According to our formula, with x equals 2 and n equals 29, this is equal to 2 to the power n plus 1, 29 plus 1, which is 30, minus 1 over 2 minus 1. And 2 minus 1 is just 1. This number is equal to 2 to the power of 30 minus 1, which is equal to 1073741,823. This is $1,073,741,823, which is, of course, much larger than the first payment option, which was just $300 million. I always trick my non-mathematician friends with this problem, and they always go wrong and choose the first option. And this concludes our problem.